Hi, my name is Anubhav Jain, and I'm a developer for the Materials Project. In this video, we'll submit a structure prediction using the Materials Project website. Afterwards, we'll explore and interpret the results. To get started, let's open up a web browser. So here I am on the materialsproject.org website. The first thing to notice is that I'm logged in. In order to use the structure predictor, you need to be logged in because the results are saved to your personal account page. If you don't have an account, you can sign up for free. To get to the Structure Predictor app, either click its icon in the front page or use the menu bar at the top. The Structure Predictor app presents a periodic table where you click elements depending on the chemical space you're interested in. For example, if I'm interested in lithium vanadium phosphates, I can click lithium, vanadium, phosphorus, and oxygen. However, we're not done yet. As mentioned in the overview video, the structure predictor is used for ionic predictions. So you must also specify the desired valences on all the elements. For lithium and oxygen, the choice is simple. In phosphates, the valence on phosphorus is 5+. In my case, I'll want vanadium 3+ compounds. One thing to watch out for, you probably don't want to click multiple valences for a single element. For example, if I click V4+ along with 3+, that means I'm looking for structures that contain both V3 and V4 within the same compound. Those structures will probably be rare, so I'm going to uncheck V4+. Another thing to note is that the overall structure needs to be charge balanced, so make sure your structure contains both negative and positive ions. In this example, the first 3 ions are positive and the last one is negative, so we're okay to proceed. The structure predictor takes time to operate, between a few hours to a couple of days, so there's an option to receive an email to notify you when the prediction is done. Once we're ready, we can submit the prediction. Now the prediction is submitted. At the top right of the screen, you can choose whether you want your results to be public or private. By default, it's private. If you make it public, you can share the results of the prediction with other researchers by copying the URL. To access my prediction, I click on my profile page at the top of the page. The part of the profile page that we care about is the section called Predicted Structures. As you can see, the prediction we just submitted hasn't completed yet. However, I happen to have another one from earlier that we can use. To look at it, let's click its ID. The top of the page tells you about inputs to your submission. You can also see the total number of structures returned. Next, we have the option to download the predicted structures as either CIF or VAS files. The latter option can be used if you want to run your own computations on the predicted structures. Finally, we have the results table. The results are ordered so that the most probable structures are at the top of the list. You could also click one of the column headers if you want to sort by something else, for example, the chemical formula. To know more about a structure, you can click its ID. I'm going to choose the 4th one down from the list because this is actually a real compound that we were later able to make in the lab. The details page contains much more information about the material, including an interactive crystal structure. You can explore this page on your own. A few things to point out. Towards the top, you can see the ICSD entry that this compound was based on. In this case, the ICSD entry corresponds to a similar compound, but with iron in the vanadium site. Another thing to point out is that you can also see the predicted diffraction pattern of your material. The diffraction pattern corresponds to copper K-alpha radiation and can help verify if synthesis goes correctly. We hope you found this tutorial on using the structure predictor useful. If you want to know more about the structure predictor algorithm, you can see our paper in Inorganic Chemistry. We also have more information on our wiki page at materialsproject.org/wiki. As always, if you have questions or comments, please send them to feedback@materialsproject.org.